Alright, reflection. Welcome back, everyone. May peace and blessings be upon you. So, there are some key principles regarding the reflection of light rays. The incident ray, reflecting ray, and the normal all lie in the same plane. If you were here last time for my refraction video, then you know what the normal is, but if you were not, let me just let you know. So, basically, the normal is an imaginary perpendicular line, and, oh, that is not perpendicular, and is perpendicular. Okay. Whatever. It's perpendicular to our surface, and our angle of incidence and our angle of reflection. Our angle of reflection are going to be equal to each other, right? So this is the angle of incidence. This is the angle of reflection, and the angle of incidence is the one that's coming in. You can remember that because of this I over here in, and reflection, this is reflected, R. So it's the one that's going out. Because obviously when something's reflected, it's not the first one. So you remember that the first light ray is the incidence. Right? So, yeah. So this black line is the normal. This one is the angle of incidence. This one's the angle of reflection. And this is like the surface, and they're all on the same plane, as you can see. Right, so the incoming light ray is called the incident ray, the reflected light ray is called the reflected ray, and the normal is the imaginary perpendicular line on the mirror surface. So the angles of the rays are measured in relation to the normal. So the normal is really important because this is how we have our angle of incidence in our angle of reflection. So the way we do that is we have, like, this is our angle of incidence, and this is our angle of reflection. As you can see, they're both relative to the normal. Yeah, so basically this doesn't matter. Yeah. So both of the angles that we're going to be using are in reflection to the normal, so the normal is really important to have. Remember, it's perpendicular, so if you're drawing, just remember it's perpendicular to the surface. So, yeah, so here we have the incident ray, here we have the reflected ray, we have the incident angle, angle of incidence, angle of reflection, and you should know that they're always equal to each other. They're always equal to each other. So the angle of incidence is always equal to the angle of reflection, as you can see over here. I didn't draw it very well, but you get the point, right? So, yeah. So the angle of incidence is the angle between the incident ray and the normal. The angle of reflection is the angle between the reflected ray and the normal. So it's always relative to the normal. Okay, so the angle of incidence is always equal to the angle of reflection, as I said over here. So just remember that. Right, so here's a drawing. So here we have the plane mirror, that's the surface, and as we can see, the normal is perpendicular to the plane mirror. And yeah, so we have the incident ray, that's the one coming in. You can see that from the arrow. I should have drawn an arrow, but as you can see, this is where the light's coming in. That's where it is going out, right? So incident ray, it's coming in. Reflected ray, it's going out. And then obviously the angles are relative to the normal, so they're in between the normal and the ray that we're talking about. So the respective ray. So reflection through a plane mirror. A mirror reflects light rays that come from various objects. These reflected rays enter our eyes and allow us to see these objects through the mirror. We can construct a ray diagram to demonstrate how the image of an object is formed inside a mirror. So you're going to want to trace at least 2 incident rays from an object. So let's start by doing that. Why don't we? First, let's just erase what we've done so far. So what should we do for the object? Why don't we do like actually, I don't want it to be too much. Let's just do a cat, okay? Let's just do a cat. So our object's gonna be green. Here is our object, cat. and it said to draw 2 incident rays from the object, right? So as I hope you remember from 2 seconds ago, incident ray is the ray that's coming in, where the light is like going towards the surface, right? So yeah, let's just, why don't we draw the mirror, right? So let's draw like our surface. This is not the normal. This is the surface. This blue line is not the normal, it's the surface. The normal would be like over here, right? Because it's perpendicular. Anyways, this is our cat. Here's one incident ray. Here's another incident ray. And remember, it's going towards the surface. So trace the corresponding reflected rays, ensuring that you follow the law of reflection. So now we have to draw the reflection. So I'm going to put I for incident. Reflected, I'm going to make a red. So that's reflected. That's reflected. Right, it's just like basically the same thing, just in a different direction. And it's going away from the surface because it's going, towards us. So yeah, so it's like the light is coming in, the light is bouncing off, it's being reflected, right? So yeah, right, I'm gonna draw R for reflected, and then it says trace the corresponding, trace back the reflected rays, and the lines should converge at a single point behind the mirror. So the red lines are the reflected rays, and you're gonna want to trace them back. So I'm gonna do it like this. See how we're tracing them back? Let's trace this one back. Oh, would you look at that? They joined. Alright, let's look at it. And the line should converge at a single point behind the mirror. That convergence point is where the image is located. Whoa. Okay. Do you guys see that? That is actually where the image is located. You see that? So now we're going to draw the cat again. Let me like label things kind of. So I'm going to put IMG for image. And then for blue, I'm going to put mirror. Well, I'll put like mirror surface. And if you're paying attention, you should know what it stands for. Right? Whoa. Didn't mean to do that. Yeah. Okay. And then just for the sake of remembering like the normal, let me just draw what the normals would be for you. The normal of this one would be here. Normal of this one would be here. As you can see, they're both perpendicular to the surface, right? So we just drew a ray diagram. Good job. Yeah, so if everything went smoothly, the distance from the real object to the mirror should be the same as the distance from the mirror to the image. So yeah, the distances look about the same. I think if I did it more accurately, it would be better. But I mean, I didn't, but we can always do it again. Okay, yeah, so this is how it should look. As you can see, here's the object. He drew the incident rays and then the reflected rays. The incident ray, yeah. Incident ray, reflected ray, reflected ray. He added the normals too, and then we have the rays of reflection, angle of reflection, angle of incidence, and then he used the reflected rays, traced them back behind the mirror, and they converged, and that's where the image was, right? So you need to be able to perform simple constructions, measurements, and calculations for reflections by plane mirror. Yeah, so that is reflection. Let's keep going. The properties of an image inside a mirror are, for a virtual image, the real images are those whose light actually converges, whereas virtual images are locations from where a light appears to have converged when traced backwards. So, as we can see here, So in real images, light is actually converging. If you don't know what converge means, it basically means join together. Like, I don't know if you've heard of divergent or divergence, but diverge, it's like spread apart, like diverse kind of, and like yeah. So diverge is like it's going away. Opposite of converge. Converge is like together. So when the lines are together, when they meet, you know, in real images, the light is actually meeting. Virtual images, it seems to be meeting when traced backwards. So see how we traced our angles, our reflected rays backwards? It seemed to converge, right? But it didn't actually. So that's how we know it's a virtual image. It should be the same size as the size of the object. So see, the cats are the same size. Same distance away from mirror as object, as you can see over here, the same distance, and laterally inverted. So that means that laterally means like this, right? So it's like side by side, I guess. Laterally inverted means like opposite. I don't know how this is a symbol for opposite, but you know what I mean. So like if someone is looking in the mirror, right? This is the person who's not in the mirror. And then we have, let me draw a mirror. And the guy in the mirror is like, this. Even though the guy outside of the mirror, like, see his arm over here, this is his right arm. But it looks like this one is raising his left arm. It's like when people say that something is mirrored, like it's the opposite direction. It's like your right is like, when it's mirrored, then it looks like your left, right? So like, your right, if you look in the mirror, you raise your right arm, it's gonna look like your left arm is being raised in the mirror. So yeah, so that's what it means by laterally inverted. And yeah, we already went through refraction, but I'm gonna do another video on that, I believe. And yeah, thanks for watching. I hope this made sense. And practice drawing some ray diagrams. Let's actually do another one, because the more the merrier, The more the merrier. I want to make this like really big. Okay. Because I can't. Right, we should draw another one just for practice. So this time our object can be, what should our object be? It can be, I'm just gonna freestyle because I can't really think of anything. Oh, okay, let's make it green again. Whoa. What is this? Where did this come from? Okay, let me just go ahead. Where did the screen come from? What? Okay, so that was a bit confusing. Right, so let's draw our object. Our object can be like, this time we can do a bunny. Oh, that's not a really nice looking bunny. But anyways, what are we gonna do first? We're gonna draw the incident rays, but first it really helps to just like have the surface drawn. So I'm gonna go ahead and draw that. So we have our surface, and then I'm gonna draw the angles of incidence. Remember, those are the angles that are like moving where the light is coming in. Right? Yeah. And then now we're gonna do the angles of reflection. they're like the exact opposite. So the light is going out now instead of coming in. It's being reflected. That makes sense. So yeah, there we go. Can't really see it, but you get the point, I hope. If you don't, just comment down below and I'll try to explain to the best of my ability. Anyways, now we're going to like trace them back, right? So we're gonna like trace these bad boys back. And then now we're gonna draw the image. You know, I think the problem is why like the distance is different, because I think I should have put it like this, you know? But you know, it's not that big a deal. We can always do another one. Okay, so I'm kidding. You should practice by yourself. If you want me to do another video, just let me know and I'll do it. Right, so there's the bunny. It's reflected. We can also draw the normals just for the normal, just like for getting familiar with it, for the sake of getting familiar with it, you know. There's a normal. Remember, it's perpendicular to the surface. And yeah, so that should, I think that's all we have to do. Let me check. Yeah, I mean, I guess we could draw the eye too, but let's not. Anyways, I hope you enjoyed this class. Let me write down the like property things before your departure. So from this video. So let's change the color. This time our color can be green. Why not? Okay, so remember, virtual images. So first of all, we know that virtual images, light appears to converge, but not really. We also know that it's laterally inverted, right? So like things are mirrored. It's laterally inverted. Same distance from mirror as the object, same size as the object, right? What else? Okay, I put everything. So yeah, so just remember that. Light appears to converge but doesn't really converge. It's laterally inverted. It's the same distance from the mirror as the object, and it's the same size as the object. These are all things that, like, if it comes up on the test, you should be able to think of it. And based on your experience using mirrors, you should be able to come up with all of these. So yeah, I hope that helped. And yeah, good luck on your tests if you're studying. If you're not and you're just learning, I hope this makes sense, and comment down below if you want any more videos or to solve, or if you want me to solve like past questions, past papers. And yeah, bye bye.